This is going to be the molar conversion, the first molar conversion from mass to moles or moles back to mass. If you've watched my previous video, what can moles convert? You will notice that moles can convert three things. So moles is your central unit, just similar to your dozen. And what moles can convert is that first one is that you can convert the number of moles into mass. Another one is that you can convert moles into a number of things. It could be atoms, molecules, whatever you want. That's your Avogadro's number. And the third one is the volume of gas. This one is strictly just based on the volume of the gas. Okay, so how we look at the mass conversion is that going back to the dozen example, if you have a dozen apples and dozen oranges and dozen teddy bears, you know that each of these ones will have a different mass for each of them, right? They're not going to weigh the same thing because they're different items. So if we were to just say that the apples would have 1340 grams for one dozen, oranges would have 2340 grams per dozen, and the teddy bears would be 540 grams per dozen, you notice that these are all for one dozen, just similar to if you have grams for one mole, would be grams for one dozen, grams per one mole, right? And if you were to write the units, you will notice that right here, those are your units. Those ones, grams per dozen, that's just similar to if we were to write grams per mole. So it's really important to understand the units because it's going to help out with your unit analysis. So this is grams per dozen. My pen is not working. So if you were to look at the next slide, here's first kind of question. So if you were to have the mass, or if you ask the mass, if you have 5 dozen apples, you know that this is how heavy it's going to weigh for 1 dozen. You can do the unit analysis for this, right? So you're given 5 dozen apples, you have 1340 grams per dozen. You can probably see that you just have to multiply these numbers together to get the answer. But how do we set this up in the unit analysis way? I think that's the key here, because knowing our units and knowing where their numbers are from and how they get canceled off, that's going to really help in the long run. So let's start off with just writing what we have. Oh, my pen is not working here. What we have here is that we have 5 dozen, so 5 dozen apples. So this is my unit for my starting point, is that I have 5 dozen, and then I'm going to times division bar, right? That's my times division bar. And because I need to get rid of dozen is going to be at the bottom of this. So this is my dozen, and my grams is going to be at the top. So what numbers are we going to include here? Well, since the question, or since this fact here is stating that you have 1340 grams, so you're going to put 1340 beside the grams. And for the unit, this is over 1 dozen. This is per 1 dozen, so I'm going to put 1 here. So then you can see that you can actually just cancel off the dozen, because dozen is the denominator and you're starting off the dozen in the numerator. So this gets canceled. And what is my number? Let me see if I can just bring my calculator here. So that's 5 times 1340. That gives me 6,700. So the answer is 6,700. And what's my final unit here? Well, grams is what I'm left with, so I have 6,700 grams. So that's for dozen. So how is that different than moles? It's actually not that different, right? So if you're to look at the same kind of question from before, you're calculating for the mass, but now you have 5 moles of copper atoms. So if you look at the previous question, you had 1340 grams per dozen. Well, where are we going to get the number of similar to this for copper? That's where you go into your periodic table. This molar mass or atomic mass has the unit grams per mole. So it's just like grams per dozen, now you have grams per mole. So you set this up the same way. I'm just going to change a different color here. Set this up the same way. Oh, this color is a little better. You have 5 moles. I don't know if this color is any better. Let me see if I can change a different color. Maybe yellow is a little bit better. Times, yeah, yellow is a little bit better. So it's because you have moles in the numerator, I'm going to have moles in the denominator, and I'm going to put grams in the top because that's what I'm trying to find. Grams is what I'm trying to find here. What is the mass? So then I'm going to put this number in, 63.546 grams, and because this is per mole for 1 mole, I'm going to put 1 mole here. So the cool thing about this is that for unit analysis, you can actually see where your units are being canceled. Moles is canceled with moles. This MOL is just a shorthand form of moles. And you can see that grams is what I'm going to be left with. So my answer is going to be, let's punch this in, 5 times 63.546. So that's going to be 317.73. So 317.73. And this is grams now, not grams per mole, because my mole units has canceled off. So in 5 moles of copper, you're going to have this mass. So that's pretty heavy for the copper. So if you really want to understand this question, it's like, well, what does that mean, right? Further later on, you're going to figure out like, hey, can I convert and can I see how many atoms of copper I would have in grams? Yeah, absolutely. Like if you wanted to figure out how many copper atoms, you can actually will use this grams, convert it to moles, and moles can be converted to number of things, right? Just like Avogadro's number. So that's our next conversion. But let's look at this question. Now we're going the other way. This is how many moles do you have if you have 36 grams. So this is just like how many dozens do you have if you have 36 grams of apple, right? And in order to calculate, like if I were to ask you how many dozens do you have if you have 36 grams of apple, you would have to wonder, well, how heavy is 1 dozen apples, right? Like we don't know that, right? So that's what we have to find. You have to be given that fact. Luckily for your elements, every element has that atomic mass. So this one, you will have to just add up all of the atomic mass for NaHCO3. So the first one for sodium, you have 22.989. So let's just round this off to 22.99 grams per mole. Hydrogen is going to be 1.0079, or just 8 since we're using 2 decimal place. And then for carbon, this is going to be 12.011 grams per mole. And then the last one, I have oxygen. Do I just need 1 oxygen? No, I need 3 of them because I have this subscript of 3. That means I need 3 of them. So I'm going to have 3 times 15.999 grams per mole. So it's almost like 16 here. So what is that? So if we were to multiply this by 3, you're going to get about 48, sorry, zeros. I'm totally just rounding this. I'm just doing this in my head. But if you were to put the decimals in, you would have like 47.97, right? So once you have all of these, then you're going to add all these numbers up. I'm just going to quickly punch it in my calculator, and then I'm going to have 22.99 plus 1.0079 plus 12.011 plus 48. And this is going to give me a total of 84 grams per mole. So this is just like, hey, in order to answer this question about apples, I need to know how heavy apples are. Well, you now know how heavy this sodium bicarbonate is for 1 mole. So set this up just like with your unit analysis way. So if you were to, let me just change my color. I'm given 36 grams, so I'm going to start off with 36 grams. And I'm going to put times division bar because grams is what I want to get rid of. So I'm going to put grams in the bottom. And moles, since I'm asked for moles, that's what I want. So that's moles is going to be, oops, just type in a number here. We're just going to delete this. Moles is what I want. So then I want that in the numerator. So I'm going to have moles here. So moles at the top. So you're going to see that my 84 grams, this 84 is not going to be at the top anymore because remember, this is 84 grams for 1 mole. Since my grams is in the denominator, I'm putting 84 right beside the grams, which is in the denominator. And because this is still for 1 mole, I'm going to put 1 right beside the mole. And once you see this, you're going to cancel out all the grams. And how do we do this math? Well, this math is just looking at 36 times 1 divided by 84. So in its essence, it's just 36 divided by 84, which is 0.4286. Let's just round it off. So it's be 0.4286. 0.36, and this is my mole, so that's what I just calculated. So if you have 36 grams of sodium bicarbonate, you only have about 0.4286 moles of it. And that's your first unit conversion. That's your converting moles to mass or mass to moles. Thanks for watching.